I'm Anil Kumar. In this set of videos, I have taken a few questions which will help you to understand rational functions and prepare you well for the test. Here is question number 1. It is rather question number 1a. The question is, describe and sketch rational function y equals to 3 minus 2x divided by 4x minus 2. In the next video, I'll take up another kind of rational function, very similar, and will again describe and sketch that function. You can always pause the video, answer the question, and then look into my suggestions. Now, whenever we say describe and sketch, what should we describe? This is kind of an open thing. Well, for a rational function, which is ratio of polynomials, denominator cannot be 0, and that leads to restrictions. So first thing which we should talk about is restrictions. I mean, the order is not very important, but anyway, there is always a starting point, right? So let's talk about restrictions to begin with. Now, in this particular case, we have this function which is y equals to 3 minus 2x. The denominator can be factored. We have 2 common, so I could write this as 2 times x minus, when I took 2 common, 2x minus 1, I'm sorry. So I could write like this, right? So 2x minus 1. So that is what we get in the denominator. Now the denominator cannot be 0. This part, 2x minus 1, leads to restrictions. So to find restrictions, what we can do here is, we can say, well, 2x minus 1 is never equal to 0, since you cannot divide by 0. So if you solve this, you get 2x is not equal to 1, or x is not equal to half. So that becomes the restriction. Now assume as you write restrictions, that really means that you're ready to write the domain. Since domain is all real numbers except for this, right? So now we can pick up domain. So we are kind of going in an order which helps us to answer the question in an organized way. So the domain for this function, we can say, well, the domain for this function is x belongs to real numbers where x is not equal to half. Now the question is, what happens at x equals to half? That gives you an idea of describing vertical asymptote. What happens at half? At half, x equals to half, we have a vertical asymptote. Vertical asymptote is a value. If x is approaching that value, then the value of the function is approaching either positive, negative, or negative, positive infinity or negative infinity, rather unbound value, right? So to show you on a graph, we have to ultimately also sketch a graph. So let me just make a rough sketch here. Let's say this is our coordinates. Okay, so let's say this is the coordinate. So what we are saying is that there is a vertical asymptote at half, x equals to half. That means, let's say this is my vertical asymptote. So this is a point where the x value is half. Okay, so that's the vertical asymptote. The graph of the function will never cross this. This is what we're trying to say here. Is it okay? So this is x, this is y. That's the vertical asymptote. Okay. Now let's talk about any other asymptote. There's a vertical, there could be a horizontal asymptote. Since the degree of numerator and denominator is same, we do expect a horizontal asymptote. So what is that? Horizontal asymptote is when x approaches a very large value, let's say infinity, y approaches a fixed value. In that case, we say horizontal asymptote exists. In this case, if I write a very large value of x, then what happens? If x approaches a large value, then y approaches what? If x is very large, then 3 is small. You approach minus 2x in the numerator and 4x in the denominator. You could use this function, right? 4x. Or you can say it approaches minus half. So we are approaching minus half value. Since we are approaching a particular value, we are not there, but we are approaching, that becomes the horizontal asymptote, right? So we say, well, this function has a horizontal asymptote, and the horizontal asymptote is y equals to minus half. Let me write vertical asymptote here as x equals to half. Is it okay? Which we have just shown here. So that really means that we are approaching a value minus half. That is how it is represented on the graph. Okay, so we know all this. Now, what happens when x is 0, right? So when x is 0, we get y-intercept. So now we can talk about what happens at x equals to 0 or y-intercept. So we'll talk about y-intercept now. Y-intercept is when x equals to 0, right? So that is x equals to 0. So if I write x equals to 0, I get y equals to 3 minus 0 over 0 minus 2, or it is minus 3 over 2, right? So minus 3 over 2, if this is half for us, let's say this is minus 3 over 2. So that becomes the y-intercept. Okay, let's also find the x-intercept. So the x-intercept is where y is 0, right? That is when y is equal to 0. So if I substitute y as 0, then calculate this. That means 3 minus 2x should be 0, right? That means 3 minus 2x equals to 0, or solving, we get x is equals to 3 over 2, right? So at x equals to 3 over 2, we have x-intercept. So 3 over 2 will be, this is half, let's say 1, let's say this point is 3 over 2, right? So that is the place where we expect a x-intercept. Now with all this, we kind of have our graph, which is looking like 1 over x. We can combine all this information and sketch a graph saying that we are approaching this, have to cross this, so the graph probably will be like this. Is that okay? And on this side, we have to go, we are approaching, but we are not quite there at half. That is the horizontal asymptote, and the vertical asymptote, which we cannot cross, is at half. So the graph of the function is as shown in this line. Now to sketch a better graph, what you could do is you could find the value of the function at few more points. For example, you can find the value of the function at x equals to 1, x equals to minus 1, and get few more points on this graph and then sketch it. Do you understand? Some more things as you go in further details is behavior near asymptote. Now we are not talking about behavior near asymptote in this particular video, but it is when you're approaching x, very large positive value, you are approaching the horizontal asymptote from the above, and that's what you can figure out. So the behavior is when x approaches positive infinity, then y is approaching from above. Do you see? Y is approaching from above this value of minus half, this value of minus half. Do you get an idea, right? So we say y approaches minus half from above, right? That is the end behavior. Similarly, when x approaches negative infinity, y approaches from below. You can calculate this value by substituting a negative large value, right? That is another way of doing it. But anyway, in this particular video, we have learned few basic concepts which can help you to draw or graph fair enough rational function, and that's why I'm calling this as test 1. So we are not getting into all details. The one which we really missed is behavior near asymptotes, which I'll discuss in other videos. Okay, so let's concentrate on this. I hope these are clear. Restrictions, domain, vertical asymptote, horizontal asymptote, x and y intercepts. And since we're talking about domain, we should have written range also. So let me write down range also here. in the characteristics, that's kind of important. You can see that the function, the y value of this function is all real numbers except minus half. So we say y belongs to real numbers such that y is not equal to minus half. So that is the range of this particular function, which I missed in this order of events. And it's a good idea to write range after the graph, since we are very sure that that is really the range, right? Because at times you'll find rational functions to have very different characteristic or graph. I'm Anil Kumar, and I hope that helps. You can always share and subscribe to my videos. Thanks for watching.